Alright, in this video we'll come to the last two problems of Larson, Chapter 4, Section 1. And again we're looking for particular solutions to antiderivatives, and we're starting with the second derivative and working all the way back to the original function. So we're going to have to integrate 2 times in order to work this out. So let's start with number 61. We have f prime prime, the second derivative of f with respect to x is x to the negative 3/2. So the first derivative then is the integral of the second derivative, and we know that that is equal to x to the negative 3/2. We're going to increase by 1 and divide by the new exponent, so that would be x to the negative 1/2 divided by negative 1/2, or negative 2 x to the negative 1/2 plus c. We have a point on the first derivative. We know that f prime of 4 would be 2 times 4. 2 times 4 to the negative 1/2 plus c has to equal 2. Then that tells us that 4 to the negative 1/2 is 1 over the square root of 4, which is 1/2. Negative 2 times 1/2 is negative 1. So we have negative 1 plus c is 2. That means that c is 3. And so we get our first derivative function to be negative 2x to the negative 1/2 plus 3. And we begin again. We know that the original function is the antiderivative, or the integral of the first derivative. And so that will be x to the negative 1/2 increased by 1 would be x to the 1/2 divided by 1/2. That means multiplied by 2. So we're going to get negative 4x to the positive 1/2 plus 3, x to the 0 increased by 1, divide by 1, increase by 1, and divide by the new exponent, which is 1. It's just 3x plus c. We're given the fact that f of 0 is equal to 0. So when we plug in 0 into that, you're going to see that c is equal to 0 here without going through that work. And we know then that f of x has to equal negative 4x to the 1/2 plus 3x. And that's it for that. Okay, we'll go on to number 62. One example of a trig function here. Starting at the second derivative, f prime prime of x is equal to sine x. So that means that the first derivative is the antiderivative of sine x, which we know is negative cosine of x plus c. We're given the point that f prime of 0, which would be negative cosine of 0 plus c, has to equal 1. Cosine of 0 is 1. Negative that would be negative 1. So therefore c is equal to 2 here. And now we know our first derivative function, f prime of x, is negative cosine of x plus 2. And we begin with the second phase. F of x is going to be the integral of negative cosine of x plus 2 dx. And we know that that is equal to, the antiderivative of cosine is sine, so negative sine x plus 2x plus c. We're given the point that f of 0 is equal to 6, so negative sine of 0 plus 2 times 0 plus c is equal to 6. Sine of 0 is 0, and 2 times 0 is 0, so therefore c equals 6, and we wrap up with f of x is equal to negative sine of x plus 2x plus 6. And that will do it for these last two problems. So hopefully you can see how we work from the second derivative down to the original function. All we need is a point on the first derivative curve and a point on the original function curve, and we can do that. All right, that'll do it for this.